Okay, this is section 8.2, the law of sines. So check out a couple of triangles. This is A is a scenario where we have all acute angles. B is a scenario where we have two acute angles and one obtuse angle. And then oblique triangle is one where none of the angles is a right angle. When we're in oblique triangle category, we can't use Pythagorean theorem, we can't use trigonometry in the classic sense because trigonometry requires a right angle. So what do? We just give up, lay down, forget it. Or we go into the law of sines. All right, case one. One side and two angles are known, also known as angle side angle or side angle angle. We use the law of sines. Case two. So case one looks like this. We know two angles and one side. Case two, we know two sides and the angle opposite of them, which is side-side angle, and that looks like this. We know two sides and the angle opposite. So the angle is outside of the sides. It's not interior to the sides. Case three is two sides and the included angle are known. So that's side angle side. And then case three is we know all three sides. The reason we go over the cases is because certain laws fit certain cases better. So we're going to focus in on specific cases in the next couple sections. Okay, so when we have case one or case two, we want to use the law of sines, and that's a pretty straightforward question that you might see on assessments. Which scenario would we use law of sines for? So law of sines is sine of angle A over A is equal to sine of angle B over B equals sine of angle C over C. You can use this in one of three ways. You can either use it as sine of A over A, actually a bunch of ways, equals sine of B over B, and then you have a proportion. Or you can do sine of A over A equals sine of C over C. Or you can do sine of B over B equals sine of C over C. So it's three equivalent proportions, and you are only going to use two of those for these cases. For angle, angle, side, side, angle, angle, and side, side, angle. Do not forget the triangle sum theorem. Angle A plus angle B plus angle C is equal to 180. It might be easier to solve angles that way instead of using the law of sines. So I was right. There are three different ways. So there are three different ways we can use law of sines. Any of these proportions. And it varies based upon the information you're given. How I remember it, it's the angle over the side, opposite. So if you have a triangle, you have angle A, side A is opposite of angle A. Side B is opposite of angle B. All right, so let's solve side angle angle or angle side angle triangles. All right, so we have a triangle. A is 40, B is 60 degrees, side A is 4. So we need to solve for C, angle C, side C, and side B. So angle C we can solve pretty quickly. It's 40 plus 60 plus C is 180. 40 plus 60 is 100. So 180 minus 100 is 80. So we know check. C equals 80. Oop. Okay. Now we're going to use law of sines to find C and B. So since we know all of the A information, so I have angle A, side A, I'm going to use sine A over A in both proportions. I'm going to use it to find B, and I'm going to use it to find C. So let's take a look at this one first. Sine of A is sine of 40 degrees over 4 equals sine of 60 degrees over B. And sine of 40 degrees over 4 equals sine of 80 degrees over C. When I solve this, I like to cross multiply and divide. So it would be sine 40 times B equals sine of 60 times 4. We're going to divide both sides by sine of 40. And you chunk that in your calculator once again. We are transitioning from last chapter we did all radians. This chapter we're doing a lot of degrees. So make sure your calculator's in degree mode when you're calculating this out. And we get 5.39 is equal to B. That goes here. So now we got to solve for C. Once again, if I cross multiply, C times the sine of 40 equals 4 times the sine of 80. Then I divide by sine of 40. And I get 4 sine of 80 divided by sine of 40 equals 6.13. That goes here. And now I have all my angles and all my sides. All right, so now this is an angle side angle. So we've got two angles and side 5. We use triangle sum to find that third angle. And we get C is equal to 130. So now we have this is a situation where we have an obtuse angle. And then law of sines says we're going to use sine of 30 over 5 as our solid informational piece. So we have sine of A over A, so we're solving for the A values here. So we're solving for side A. We use sine of C over C because we have both 130 and 5. So we can fit those in and have those only one unknown. Cross multiply and divide by sine of 30. So I get 5 times the sine of 30 divided by sine of 130, sorry, 35, divided by sine of 130. And then that goes here. I'm going to again use sine C over C. I would avoid using, even though you know angle A is 35 degrees and side A is approximately 3.74, I would avoid using that to solve for B because we have rounded in this situation. You don't want to use something that you've rounded or solved for because A, you've rounded, so it might change if you've, depending upon how many decimal places you've rounded to, it might change the answer a little bit. Or if you did it incorrectly, then not only will you get that one wrong, but you'll get the next one wrong for sure. So it's safer to go ahead and use sine C again, since we know those ones for sure. So that's again a cross multiplying 5 sine 15 divided by sine of 130. And that's approximately 1.69. And then we've solved for that triangle. All right, let's go to the other case, side-side angle triangles. These are a little bit tricky. Sometimes we do not know if we're going to get the ambiguous case. So the ambiguous case sometimes happens in a side-side angle situation. So if we're trying to find angle A, the sine of angle A is, we use the height of the triangle to give us our right angle. If A is less than B sine of A, then side A is not long enough to make the triangle. So if side A is less than B sine of angle A, then side A is not sufficiently long enough to form a triangle, and we have the ambiguous case, no triangle. You can't solve this. No solution. If A is equal to B sine of A, then you have a right triangle. And we know how to solve that. Solve it just like you'd solve any regular right triangle. If A is greater than B sine of A, then you have two possible triangles. You have an oblique triangle that could possibly be this, or you have an acute triangle that could possibly be here. When we get the case of two possible triangles, we have to solve for both of them. So if the instructions are solve for the triangle, it's this third case where we get two triangles. We have to find all the information for both triangles. And in this scenario, A is going to be the same, side A is going to be the same, angle A is going to be the same, and side B is going to be the same. It's the angles and the side C that will be different. If A is greater than or equal to, so we're combining the last greater than or equal to B. If A is greater than or equal to B, only one triangle can be formed. Let's look how that's different from here. A is less than B. So if we have this scenario where A is greater than B sine A, and A is less than B, so A is smaller than our side B, then it's two triangles. So if A is greater than or equal to B, only one triangle can be formed. A is greater than or equal to B, one triangle. Okay. All right, so let's solve this triangle. Thankfully, I know that I only have one solution because it says in the instructions. Okay, so if A is equal to 3, B is equal to 2, and A is equal to 40 degrees. We go sine of 40 over 3 because we know angle A and side A is equal to sine of B over 2. Once again, make sure your calculator is in degree mode. So we multiply 2 sine 40 equals 3 sine B, and then divide by 3. So 2 sine 40 degrees divided by 3, you inverse sine to find that B is equal to 25.4 degrees. So if we do the test where we go B sine of theta, so we go 2 times the sine of 40 degrees, we get 1.28. So 1.29 if I'm rounding to that place. So that puts us in the scenario of A being greater than B sine of angle A. So I have two possible triangles. So the first triangle you solve just like you would a normal triangle. So that's where we get the 25 degrees. We solve it just like we normally would. Find angle B is 25.4. To find the second angle, to find the angle for the second triangle, you take 180 and subtract your B, your original, your first angle. So we're going to solve this triangle if B is equal to 25.4, and we're going to solve this triangle if B was equal to 154.6. So if we look at this, 154.6, we can rule that out because 40 plus 154.6 is greater than 180. Can a triangle's angles be greater than 180? No. So we know we don't have to fuss with the second angle. All right, so let's just fuss with that first angle. So we got 180 minus 40 minus 25.4. So our angle B is 114.6. Then we solve that. We have to use that angle to find side C because we only have solved for angles. We don't have anyone that's not a solved for angle. Awesome. 4.24 for C. So we cross multiply, divide by sine of 40. And we got, so make sure we put everything on our triangle. Angle C is 114.6, angle B is 25.4, and side C is 4.24. If we have two solutions, and I'm going to be honest with you, I didn't memorize the B sine of A information when I was going through this content because I would just solve it. If you solve the triangle like you normally do, if you get a no solution, then your calculator pops you out an error message when you try to fuss with it. If there are two solutions, when you subtract your angle B from 180, you get a possibility. And then if it's a right triangle, that you can solve a right triangle the same way you solve using the law of sines. So I did not memorize the formulas. I just tested the angle. So anywho, let's roll this out. In this case, B is greater than A, and B sine of angle A. So I'm going to do 8 times sine of 35, and I get 4.59. So 4.59 is less than 6. So my test is I have A is greater than B sine. B, oops, did I do 8? Yeah, 8 sine of 35. And then A is 6, B is, so A is greater. Okay, so yeah, I do have the two possible. A is greater than B sine of A. And our side A is smaller than side B, so it's going to get us two possible solutions. Okay, so let's law of sines with what we have. Sine 35 over 6 equals sine B over 8. You're going to cross multiply and divide by 6. So you get 0.76, and then inverse sine. So we get B1 is 49.9. We subtract that from 180 to find B2 is 130.1. Then we add that to 35 and see if we have room or if we're greater than 180. So 130.1 plus 35 is 165.1. Plenty of room for another for that second option, so this is a two solutions scenario. So we go ahead, our first triangle, we're going to find the C value. So if we use 49.9 for C, for B1, we go 180 minus B1 minus 35 gives us 95.1. So then we use 95.1, sine of 35 over 6, sine of A over A, equals sine of C over our first C side. So when cross multiply, we get C1 times 35 degrees equals 6 times sine of 95.1. Then to solve for C1, we divide both sides by 35 degrees to get us this fraction right here. We chug that in our calculator and we get that our first side C is 10.42. And then we solve for our second triangle. So we're using 130.1 as our second B. So we go 180 minus 35 minus 130.1 and we get 14.9 degrees. We're going to redo this proportion. So we get sine of 14.9 divided by C2. Solve it the same way. And we get C2 is equal to 2.69. That's the short one. So we put all those on our triangles. We see the smaller triangle is this guy with the smaller angle C, and then the bigger triangle is obviously the one with the obtuse angle C. Okay, so let's look at a scenario where I get no solution. I know that if A is less than B sine theta, or sorry, sine of A, there is no triangle. So I'm going to go to sine 50. That's 1.51. Let's just roll this out. Sine A over 2 equals sine of 50 degrees over 1. Cross multiply. Take the inverse sine, and I get A is, so I go 1.2 sine 50. Oops. So I take the inverse sine of the answer, and I get no solution. So when you plug this into your calculator, inverse sine of 1.53, I get an error message on my calculator. When that happens, there is no solution. That's why I was saying it's not very good. It's important to know, but I didn't have this memorized because when you go to solve it, you'll get a no solution. Side C just is not long enough to touch the triangle with an angle of 50 degrees. So sad, little picture guy. And now, the problems you've all been waiting for. Applied problems! Yay, word problems! The best thing ever. Okay. Height of a mountain. A surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. See the figure. The first observation results in an angle of 47 degrees, and the second has an angle of 35. If the transit is 2 meters high, so 2 meters off top from the ground, what is the height h of the mountain? So the first thing we do is we separate out and write just the triangle so we can get a clear view of how we're going to solve this. So we have this triangle here, this oblique triangle. He's got angle A, 35 degrees, angle C, 900 meters, and side C. He shares a side with this right triangle here, who has an angle of 47 and a height of 2 meters plus whatever the height off the ground is. So the first thing we can do is we can find angle C. Because they form a straight line, angle C is equal to 47 plus C, the two of them combined to equal 180. So I know C is going to be equal to 133. We can put that right on our angle. Now that I have 133, I can find angle A. So angle A is 133 plus 35, that's sum, minus 180. So angle A is 12. So this is 35, this is 133, and angle A is 12. Now we can use the law of sines, because we know sine of 12 over 900 equals sine of 133 over C. Cross multiply and divide by sine of 12. And we get 3,165.86. That's this distance right here, the C. All right, so if 3165.86 times sine of 35 is 1815.86, which is about 16 meters, or 1,816 meters. We need to add the 2 from the bottom where this guy is standing to get the height. So that's 1,818 meters. Ooh. Okay. Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. This call to Station Zulu indicates that the bearing of the ship from Zulu is north 40 degrees east. The call to Station X-Ray indicates that the bearing of the ship from X-Ray is north 30 degrees west. How far is each station from the ship? If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Man, 200 miles per hour, that sounds awesome. Okay. So we got Zulu, we got X-ray, we got the ship. We know the two are 120 miles apart. We know that our ship is 40 degrees from in the northeast direction from Zulu, so that's 40 here. That leaves, since it's a 90 degree total, that leaves 50 degrees for the interior of our triangle. Same thing with X-ray. We know that our ship is 30 degrees northwest, so here's northwest of our station. That leaves 60 degrees to be on the interior of the triangle. So we know 50, we know 60, we know 120, we don't know B, we don't know C, and we don't know A. So to find angle C, we subtract 50 and 60 from 180, and we get 70. Nice. Round number. Thank you, ship, for going into distress right at that exact angle. So we go sine of 50 degrees over A equals sine of 70 degrees over 120. Cross multiply. A sine 70 equals 120 sine of 50, and then divide by sine 70, and we get A is 97.82 miles. So we are 97.82 miles from this ship to X-ray. We do the same thing from Zulu to this ship. So we go sine of 60 over B equals sine of 70 over 120. Cross multiply, you get 120 times sine 60 equals B times sine of 70. divide by sine of 70. And you get your 110.59 miles. Now, if you're a smart cookie, who do you deploy to go save this ship? The distance from X-ray to the ship is smaller than the distance from Zulu to the ship, so we're going to send X-ray on its way. So Station Zulu is about 111 miles. Station X-ray is about 98 miles. So if we're going to send the helicopter from Station X-ray, we pick distance equals rate times time. We know our rate is 200 miles an hour. We don't know our time. We do know that the distance is 98 miles. We're going to plug that in. So the time is equal to whatever our A value is, 97.82 miles, divided by 200 miles an hour. It's going to be 0.49 hours. You multiply that by 60 to get 29 minutes. So we were just going to hope the ship doesn't sink in 29 minutes, depending upon its distress. All right, so law of sines comes from taking an oblique triangle and throwing down the height in the middle of it. So what do you do when you don't have a right triangle? You create one by putting the height of the triangle on our triangle. In doing so, we now have a right triangle and we can have a relationship between sine C equals h over a, and that's why we use these terms to find to test to see what kind of triangle we have. So you can do that to any triangle. So if you are in a pinch, you have no idea what to do with the triangle, you can't remember law of sines, can't remember law of cosines, throw down a altitude on your triangle and create yourself a right triangle. You can roll right triangle trigonometry that way.